Fractions. So when working with fractions, we need to be able to work out what a common denominator is, which is when a denominator of two or more fractions is exactly the same. We must have common denominators before we can add or subtract fractions. To find the lowest common denominator, we need to determine what is the lowest common multiple of the two denominators. We also need to be able to place fractions on a number line. So what we need to do is we need to determine the common denominator of the fractions, convert each one using that common denominator, and then create a scaled number line to be able to place each of those onto it. We also need to be able to compare fractions, and what we need to do is we need to be able to compare them using equivalence, and so to do this we make sure that each fraction that we're comparing has a common denominator, and then we can compare with our less than, greater than, or equal sign. So our success criteria: I can place fractions on a number line, I understand that fractions can be positive, negative, improper and mixed numbers, I can compare fractions using less than, greater than, or equals to, I can compare fractions using equivalence, and I can express one quantity as the value of another. Our lifelink is that medicines, so depending on an age, you will have a fraction of a dosage. Time also has fractions, so half an hour, quarter of an hour, 3/4 of an hour. And so to calculate the total time operation with rational numbers will be required. So our worked examples. So example 1, I want to find out what is the common denominator of these fractions. So our first one here, we've got 2/5 and 3/10. So I'm looking for what is the lowest common multiple of 5 and 10. Now, looking at them, you know that if I count up in 5s, I'm going to go 5, 10. So our lowest common multiple here will be 10. So our common denominator is going to be 10. Here we've got 6 and 9. So if I want to find our lowest common denominator, if I count up in 6s, I've got 6, 12, 18. If I count up in 9s, I've got 9, 18. So our lowest common multiple will be 18, which will also be our common denominator. For C, I've got 4 and 6. So counting in 4s, we've got 4, 8, 12. 6s, 6, 12. So our common denominator is 12. And then our final example here, we've got 5 and 7. So if I count in 5s, I've got 5, 10, 15, 20, 25, 30, 35. If I count in 7s, we've got 7, 14, 21, 28, 35. So therefore, our common denominator that we would use is 35. Okay, work example 2, we want to compare using equivalent. So we want to get a common denominator and then compare from there. So you can see here our denominators are 4 and 8. So our lowest common multiple of 4 and 8 would be 8. So I need to alter our first fraction so that we have a denominator of 8. So I need to multiply by 2. Whatever I do to the denominator, I must also do to the numerator. So then my fraction will be 6/8. Now 6/8 is equivalent to 3/4. So I've got 6/8 and 5/8, and now 6/8 is greater than 5/8. Okay, our next example, I've got 12 and 15, so our common denominator. So if I was to write out to find our lowest common multiple, we've got 12, 24, 36, 48, 60, 15, 30, 45, 60. So our common denominator will be 60. So to my first fraction, to get from 12 to 60, I need to multiply by 5. And our second fraction, if I want to get from 15 to 60, I need to times by 4. So I complete those operations. So then here I'm going to have 5/60ths and I'm going to have 8/60ths. So then I put in my symbol. So 5/60ths is less than 8/60ths. Okay, for C, I've got 1 1/5 and 1 2/7. Now what I'm going to do is I'm going to change both of these to improper fractions. So how we do that is we do 1 times 5 plus 1, and that becomes our numerator. So 1 times 5 is 5, plus 1 is 6, so that's going to be 6/5. And here we've got 1 times 7 plus 2, so that's going to be 9, so that's 9/7. I then have a look and say, okay, well, what is my common denominator going to be of 5 and 7? So if I write 5 and 7 here, we've got 5, 10, 15, 20, 25, 30, 35, 7, 14, 21, 28, 35. So our lowest common multiple is 35. So that means that our common denominator will be 35 as well. So what I need to do is I need to multiply 5 by 7, and we do the numerator and denominator both by 7, and 7 by 5. So here 6 times 7 is 42, 9 times 5 is 45. So then comparing them, 42 35ths is going to be less than 45 35ths. Okay, and our last example on this one, we've got a half and a third. And so our common denominator is going to be 6. So to get to 6, 2, I need to multiply by 3, and I need to do that to my numerator as well. And to get from 3 to 6, I need to times by 2, and we do that to our numerator as well. So 3/6 is equivalent to a half, and 2/6 is equivalent to a third. So what it means is 3/6 is greater than 2/6. Now we can write it as our original fraction, so a half is greater than a third. Okay, worked example 3, we want to place the following fractions on a number line. So the very first thing we need to do is we need to work out, okay, what is a common denominator between all of these values? So you can see here we've got 2, 5, 10 as our denominators of our fractions. So if I was to count up in 2s, I'd have 2, 4, 6, 8, 10. 5s, 5, 10, count up in 10s, 10. So you can see we get to 10 on all of them. So our common denominator is going to be 10. So the very first thing I'm going to do is I'm going to change each of my fractions so that they have a denominator of 10. So our half, you're going to do 1 times 5 over 2 times 5. Negative fifth, so it'll be 1 times 2 over 5 times 2. 3/5, we will also be multiplying by 2. Whoops. 4/10 will just stay the same. Negative 9/10 will stay the same. And then 1 1/5, I'm just going to change that into an improper fraction. So 1 times 5 is 5, plus 1 is 6, so that's 6/5. So 6/5 we will need to times by 2. So the fractions that I need to place are going to be 5/10, negative 2/10, 6/10, 4/10, negative 9/10, and 12/10. So I then need to get out my ruler, and I rule a nice straight line. And then what I'm going to do is I need to mark each of those increments. Now you can see here that I'm going to need to have to go from -1 up to just over 1. So what I'm going to do is I'm going to mark So it's really important that we have a nice even increments along our line. So you can see here, I've marked each tenth as we go up our number line. So if I've got -2, -1, 0, 1, 2. So 5/10, that's going to be halfway between 0 and 1. So 1, 2, 3, 4, 5. So here 5/10, and the original fraction that we were meant to place was a half. -2/10, so that's going to be 2 below 0, 2 of the increments that I've marked. So 1, 2, and -1/5 is equivalent to that. 6/10, so that's going to be positive. Now it's going to be 1 above our half, which was 5/10. So 6/10 is equivalent to 3/5. We then have 4/10, -9/10. It's going to be 1 before -1, because remembering that negative 1 would be negative 10 on 10. And then our last one was 12 tenths, which was 1 1/5. Okay, and that's how we place our values on the number line. Okay, and our last example is to complete our equivalent fractions. So here what we want to do is we want to go through and work out, okay, which spaces can we fill in that will help us to fill in the rest. So the very first one that I'm going to do here is I know that 16, to get down to 4, I need to divide by 4. So I'm going to do the exact same thing to my numerator. So 12 divided by 4 is 3. What this then allows me to do is I know that 3 times 2 is 6. So 4 times 2 is 8. I also then know that 4 times 5 is 20. So 3 times 5 is 15. I can then go and say that 4 times 6 is 24. So I'm going to multiply by 6 to get the numerator, which will be 18. I then know that, 4 times 3 is 12. So we multiply our numerator by 3 as well. So 3 times 3 is 9. And then to get to 21, I know that 3 times 7 is 21. So then I also multiply my denominator by 7. So 4 times 7 is 28. And you can see we filled in all of our equivalent fractions there.